Okay, we're good. Right, so the topics. Oh, how much time have you got, by the way? You sound under pressure.
I have some other stuff to do tonight, but I want to. Okay, you have my attention. Andrew's just asking about dinner.
That's an important topic. It's probably one of the highlights of my day, actually, as tragic as that sounds.
I just said get sushi, so you have my attention.
Okay. So the ORM topic I wanted to cover, the way that I've made base classes to act as an ORM is also another topic. The fact that do I even need to concern myself with being an ORM, given that I'm only building these classes for internal use. Those were the code topics I wanted to cover. The entropy discussion that you kicked off, which I wholeheartedly agree with. I'm just grasping to sort of link it to metaphors cleanly. There's definitely it. I mean, you're right. It's inflation is a form. It's got to be a form of entropy. It's just, is there a nice way to sum that up, and how can it help us? And then the third topic I was hoping to touch on was Ukraine and some work that Mr. Maxwell and I have been doing around that topic.
Okay.
Where would you like to start?
Let's start with the code. The ORM.
The easy one. Okay. All right, so have you got that link in front of you to ipld-struct.js? I think when I first asked for a meeting, that was the link I provided. It has since been overtaken by events.
Mm-hmm.
I'll paste it. I can paste the chat again.
No, I'm good. I got it now.
You got it? Yeah, okay. So what I've done is I've made a base class that has I defined IPLD interface. I don't know if that's clearer to look at than this. IPLD struct is the main class that everything inherits from, and I tried to make it so that all the data that it represents is stored as plain JSON attached to this. You can specify a class map which lists the keys that you want to transform and squash down from other classes as well. So it can basically at the top of the tree, I can call crush, and crush goes through and converts everything to IPLD blocks. And then I can also, hey?
When you say everything, like, do you mean basically everything that's set with set?
Yes.
Like, is there, okay, what I'm trying to get at, is there like are you keeping track of which things are references and which things aren't, or are you just saying that, like, basically you want to put every single value primitive like in its own node in IPFS?
I think I get what you're saying. As it turns out, that is not an either-or answer. And so what IPFS allows us to do is you can store a deeply nested object as well as something that gets punched out as a CID. And so I've used the class map feature. So every child class of this parent class has to supply, optionally can supply a class map where that specifies what keys will be on this object will be punched out and replaced with CIDs when I call crush. And so it actually stores then two different values for the object. When crush is called, basically these objects act like a cache until you call crush. When you call crush, they recursively crush all their children too, if they are defined in that class map, and each object will return a new version of itself where the cache is now flushed and there is an IPLD block attached to it as well. So you can then afterwards, once you've called crush, you then call get diff blocks, and get diff blocks provides you the IPLD blocks for the object in question and all its children, based on what changed from the previous version of the object.
Okay. Now, so you're keeping a list of, like, what I'm saying is that the JSON structure it's a tree basically, right?
Yeah.
And you're keeping a list of addresses on that tree that you consider to be discrete, like, data units that need to be tracked independently in their own address on IPFS.
Correct. 100% correct. Keeping in mind that any change of a child results in the change of the CIDs of all the parents as well.
Right. Yeah, you're bubbling the hash change up to the top.
Yeah, the hash change bubbles up, but it's an arbitrarily defined tree that I chose based on the schema that I defined. So I chose where the node points were, and everything else is plain JSON.
Right. So the reason I was asking is because you obviously could extend that out to be like every single primitive value in the JSON object would have its own address in IPFS.
Yeah, but the trouble is, first of all, speed becomes an issue, and second of all, data size. Like hashes are 32 bytes, but you might be storing a bool. So, if you hash your bool every time.
Well, I mean, theoretically, really small spaces like that, you should be able to capture the whole space and use it statically. Like, there's really only two Boolean values, right?
There's another part to this design that is that I tried to group things in that structure, group things that wouldn't change often, so that they have their own hash. So that from block to block to block, because I don't expect it to change much, the hash ought to stay reasonably stable. So it was a lot of balancing, really, to get the structure. But I guess I'm also asking about the API that I've settled on, which is this crush, uncrush, and get diff blocks.
Yeah, I mean, that sounds like all you would ever need. Like, give me the skeleton, give me the meat, and tell me what changed. Like, skeleton is for when you're rapidly trying to get in sync with somebody, right? Meat is the actual usable data with
Yep.
And diffs, just pretty much the diffs are the point, right?
The diffs are absolutely the point, yes. There was another issue that I faced, which was when I was using there's a hash array map try implementation. One of the guys from IPFS has helpfully made, which allows you to basically, it provides you a hash map where it sort of balances the nodes automatically for you, so you can have an arbitrarily large hash map and it decides when to split blocks. I have used that mostly in the network object because that's the tricky piece that needs to grow arbitrarily large. So where am I going with that? Well, the thing I wanted to, the design decisions that I made are that, like you had suggested, I made address be also an alias.
Mm-hmm.
So whenever you resolve the address of something, you're simply adding an alias to the network object that points to that channel ID. And that's done so that you can't make an alias for something else that looks like an address but isn't,
right?
Which I thought was a good safety feature. So one of the problems is, should I be allowing arbitrary IPFS lookups during block making? That's sort of the tricky thing, right? Because if you've got a chain and you're trying to block it, make the next block, but for some reason someone denies you access to a part of that chain, it's going to be loaded in the isolator and it could sit there a while consuming resources, but you've been denied from the larger piece of the chain.
Right. Which, I mean, will actually be a really common case, right? Like people just revoking permission without broadcasting that they're revoking permission.
Yeah, but then it's like, if you are the validator, you should have the full chain, but then that puts a size limit on the chains, because now and a delay, because you now need to fetch the whole thing before you can make even a minor change. So now that I say it out loud, I'm probably worrying about that prematurely, and we can just wait and see what happens, because it's actually really nice to not have to fetch the entire chain or the entire block just to make, one change.
Yeah, I think the other thing too is, are you worried about like the adversarial angle here, like somebody trying to halt processes by being bad actors?
Yeah, because you can. There's two sides. First is, you could be malicious and you could cause a block, a validator, to use up its isolation resources. So it would begin blocking, and then it would have to pause for a very long time, and so it would move on to the next thing, and then it would pause for a very long time, and then you could end up with it waiting mid-block for a whole bunch of stuff, and then you've run out of Docker containers or whatever isolation mechanism you're using, and you fall over. So there's that. But the second thing is that if you have to load everything, well, yeah, I mean, there's a big delay when you have to load everything up front anyway. But yeah, sorry, I don't think I drank enough coffee today, but I forgot what the second point was. But
can I like?
Oh yes, sorry. The second point was time, because we make block time by overriding. Well, we will override date.now, but basically the concept of block time is when you started blocking, this is the time, and anytime you ask what the time is, that's what it is. And the assumption, which is implicit, and we never really brought it up to the surface, is that you're receiving all your actions as quickly as possible on a JavaScript thread. But if you wanted to do something that requires fetching from IPFS and the network is slow or unavailable, block time stretches, and you're being told what the time is, but it might be a long time after. Now, should your action reject, like you've been sitting in the queue you've been waiting for an hour and it reject or not? And I would say that actually no. And the solution that I had implemented was this concept of ensure. And so did you have something to ask? Because I'm about to just ramble for a bit. I
did. I want to distinguish between two different cases here.
Okay.
there's case one where like I'm rehydrating data on my chain, in which case I think the answer is like you can't, like you have to allow it to take as long as it needs to take to fetch like your data,
Right.
because the contract that we're guaranteeing is like this is your data. Like if
Yeah.
you think again about chains as like a trust boundary, right?
Yeah.
Like
They absolutely. That's what they are. Yeah.
anything that lives in my chain, like that's punched out right now. So, like, I guess what I'm trying to get at is like, I guess you have to think about why things are being punched out and like to what degree they are being handled by another process. Because now, if I think about like joining data in from foreign chains and like sticking it on a node in my state tree where I can act on it, like I don't
Yes,
think
somebody, one of the validators must have walked it before it's allowed to join the chain, I think.
right. Right. And like then you're basically like asking for that chain to guarantee to you that this thing will be like either provided to you or like it will be explicitly communicated to you that like this is no longer going to be provided to you.
Yeah.
So you'd
So
better
that
have some sort of
I would
mechanism.
expect that every validator, as part of its normal operation, would periodically call a function called scrub, where it would
Mhm.
walk all the chains that it has committed to, and it would fetch and check the hash of each one, and it would attempt to prepare it preemptively if it didn't have it.
Although I think I just said something wrong too, because like you what the Byzantine general thing, right? Like you have to assume that there's like structurally there's no difference between like malice and like slowness,
Yeah,
right?
yeah, you can't you can't be Byzantine when it comes to simply fetching hashes, but you can slow things down.
So you are envisioning an explicit response from like a foreign validator saying like you'd better not be basing important calculations on this because it's not yours and you don't have permission for it
No,
anymore.
no, no. The foreign validator, if it finds that any piece of hash content has been proposed to be included in the chain state, will fetch it before it
Okay.
gives it the tick. So the specific type of data slowness I'm referring to is old data in the chain that was once checked that may have been evicted from the local cache.
Right. So there's two types of punching out that we're talking about at the same time, and that's where I think the
Oh,
ambiguity is
right. Yeah,
coming
you're right.
from in
Yeah.
my head, right?
Yeah,
There's
you're
like
right.
punching out stale data in my trust domain, and then there's
Yeah,
punching out data that's being joined on from foreign domains.
absolutely. Yeah. Two different things.
Um,
That's a good
now
distinction.
I think they have two different contracts actually, right?
They absolutely do. But they, I see no point in allowing foreign unverified data to be considered part of a chain state. So I think that it's that local cache. If you
Mhm.
included a remote hash, your local cache must include it at the time of blocking. If it then gets evicted and you're relying on this remote store of it, that's sort of not our problem because our version of the software wouldn't do that for you. But
Mhm.
I think that's a good rule to stick by. If you're going to include it at the time it was included, you definitely got it and assured that it was correct.
Right. Now, as for like stale data that I'm clearing out of my trust domain, um, the validator has to be able to go back arbitrarily far in fetching that,
Yeah,
I think,
yeah.
because so the type of attack that can happen here is an attack where someone has recognized a bug in my code and they're like DDoSing my chain through my own like code, basically.
Um,
Or just denial of service, I guess, right? Like,
yeah, it could also be a legitimate slowdown of the network, and the only real impact is block time suffers, and
mhm.
your chain's responsiveness suffers as a result. So you get a skewed view, your code gets a skewed view of what the time is. It might be an hour late. And also your code takes a long time to respond to anyone because it's stuck waiting for this slow data to be retrieved. So I had a solution to this.
Okay.
And the solution was that I have changed the meaning of pooling. Now, pooling is no longer a collection of things. Pooling is making a new block where there's only one validator has signed it so far, and it's not considered final.
Okay. Yeah.
And so
the pool lives inside the chain, like some crippled version of the chain, basically.
Well, it's a soft version or a preemptive, or it's not. It's a pre-consensus version of the chain. And the way that blocks work is that the pools ought to be additive. So if I have one and my peer has a different one, they should merge together and come out with a third one that includes them all. There should be no way to have a conflict in the pool. It's a conflict-free data structure in a way.
I mean they're hash keyed, right? They're CID keyed, aren't they?
They are CID keyed, but it's all about the way that the data is mounted within the chain structure. Because they are mounted in a way that is additive, then any combination of two different pools starting from the same block can also be added.
Right. They're like somehow or another they're a set data structure. Like if there is an overlap, like it doesn't cause tagged disjoint unions. It causes like one common pool. Like it's like an object that's keyed by hashes, basically, right? That's how you're mounting it.
Keyed by hashes. It's collision free. Like you can't have collisions, and that's a good thing.
If you get a collision in there, it's extremely rare, and it's like universe destroying level bad.
Yeah. So there's basically the time that you need to fetch previous data from a chain can be split into 2 times and 2 times only. Number one is when during the pooling phase, you will need the pooler will need to fetch the previous data to verify that the proposed incoming data is valid to be attached to produce the next soft block.
Or by soft block, you mean like a pool block?
The pool block. Sorry. Okay. Yeah.
Okay. Yeah. And are you preemptively running the actions as well? Like you used to, that's your term soft block is drifted.
Has it? Sorry.
Yeah, you used to use it to mean like I'm processing, like I'm getting ahead on my action pool without talking to the validators.
Oh, it's still the same thing.
Right.
But the what I realized later was that you all have to at least agree on some version of the soft block to begin work on. Otherwise, a particular validator can distort what's in the pool block to suit them or to sway the calculation some way.
Right.
So there is some nuance there in terms of the group has to accept what at least the minimum soft block is, or the pool block, and then you're welcome to preemptively begin the processing before anyone else has finished their processing. So basically, so long as you've got at least a version of this pool block that at least a quorum has agreed to, you can begin processing the actions from it before someone else proposes the next block.
Meaning you, like, once you've agreed on the order, you can preemptively calculate the actions. Not the order. By the time
not the order. Once you've agreed on the contents, the order is derived from the contents. So I guess you're saying the same thing, but more directly, you're agreeing on the pool is this far full, and then there's a formula for calculating the order from that in a deterministic way. There's only
that's your twister thing, right? Your Mersenne twister.
Yeah, which is super not a twister right now. It's just the first come, first served. But that's the place where the twist is needed so that it's fair.
Mm-hmm. Okay, so I just got flashes in my head of something, probably just way off topic. No, it's good. To the extent that your action order is actually commutative, like you could always process the effect of the action as soon as you received it in the pool. And basically, like that additive property that you're talking about with the pool would end up being an additive property for the chain state. You could literally
that doesn't always apply, because if you had some independence between the state and each channel, and in some use cases you can do that, like a chain may not alter its state based on actions that are coming in, and you could say that or explicitly say that, which would allow you to process the actions in any order and in parallel. But the current model is that because you might have changed the state from one action to the other, we can't run the actions in parallel.
Yeah. So like there's an extremely narrow set of cases where that would hold. Commutativeness is like actually a really difficult bar.
But it is a huge speed gain to allow the validators to begin processing of actions all in parallel without waiting for a finished version to come through. That's very, very useful. And moreover, the same mechanism that is to be used for synchronizing on the soft block is exactly the same as used for transmitting pool updates between validators too. There's no longer any difference in that mechanism.
Right.
Which I thought was useful, because you receive a new soft block from someone and it's got something you don't have, you grab it. Now you're at that version.
I was thinking of one level even more. I don't want to derail this too much, so I recognize we have limited time. Can I have a minute?
Yeah, man. You can have several.
Like, if you could have that guarantee that the actual state transformation was commutative, which like doesn't hold in a lot of scenarios, but like a really simple one would be, I am updating an array in the state where I know that there's no collisions on the indices.
Or when I explicitly use conflict-free data types in the state anyway.
Yeah, exactly. Then what you could do is your soft block could actually be processed all the way through by an individual validator.
Yeah.
And like the moment that the action was pooled. And like it would literally be like adding the blocks together to create a full block. Like you wouldn't need to run anything. You wouldn't even need an isolation at that point. Like
you'd need an isolation to execute the action, but not to combine everyone's pre-computed results. Yep. So
it might be a speed boost on certain data structures, like a crazy
structures. That would be an enormous speed boost, and it might prove to be a crucial speed boost in a low latency application. Let's put it off to the side. The second place where you need to fetch previous data is if when the system is running, it basically it goes receive and then it goes transmit. It always does that in that order, where transmit is optional as well. Receive is compulsory, transmit is optional. And so one solution I have is that when you go transmit, there's no way for me to know ahead of time which channels you're going to want to talk to. So that's a place where you might need to fetch arbitrary history from the chain to piece together what channel you're transmitting to so that I can add your transmission to that channel. So what I can do is I can buffer all of the transmits until after all of the receives have occurred. And so so first of all, the pooling happens and it can take arbitrarily long. And if I can't fetch something from history, it misses out. Sorry, too bad. This is what the pool is. And then I can rapidly do all the receives and I can just buffer all the transmits, and then I can stop blocking, pull it off the isolation device, and then I can process all the transmits, taking arbitrarily long to fetch missing data.
Yeah, that makes sense.
But the downside, or the bit that I can't quite nut out, is that if one of your actions is a transmit to the loopback to call the system to remove a channel, then I need to have processed that before, because you might expect that if you tried to send to it after, it would have been deleted.
Yeah, no, I mean, I think
it's a great system except for that problem.
Right. So again, I need a refresher here. The inputs from other chains are like proactively fetched before I try to block, basically, right?
They have to have been in the pool before you try to block, before you get loaded up into the isolation container, and it's like, go for it. You've got 200 milliseconds. Don't waste
it. And it's the output channels that are basically belong on my chain, in my trust domain.
Yes.
Okay.
But in order to transmit, I need to fetch what was the last transmission on that channel, which could be arbitrarily far back in history, and I don't want to sit there waiting for it.
Like, what's the problem with like not punching out that piece of metadata?
Size, because the network object is the one that gets huge. The exact use case in question is with the CRM model. I end up with one chain holding 20,000 customers. That turns out to be a lot of data in the network object to track all the hashes of all the chains that it needs to talk to.
Right. So, like 20,000 I assume that the data structure that you're trying to grab there to indicate staleness is the hash of the foreign chain, right? The block hash?
Yeah.
Okay. And like it's too expensive to store 20,000 like hashes internal to my chain, like on that network.
The thing I'm getting at is that to hold them in the cache all the time, or to load them up just when like one of those chains, like let's call it 1 million chains, just to accentuate the problem, if that system stays dormant for a year and then a single action comes in on one chain of the 1 million, I do not want to have to load the whole million. I just want to get in there, do my one action, and load as little as possible so I can shit and get off the pot, as the saying goes.
And these are all, you're only worried about the inbound side, basically. Or are you worried about the outbound?
I think inbound's fine because it's taking care of slowness in recovering previous data is taken care of during the pooling process, because the pooling process is sloppy and doesn't need to wait or halt for anything. But blocking is time critical. Actually, I think there actually isn't a problem with what I just said, is like caching all the transmissions I'll just make sure I'll process loopback. And if you try and do something to one of the deeper chains in loopback,
Mhm.
I'll just I think I can do it preemptively. Like I can assume that the result is going to happen because you're in full control of your own chain.
Right. Like that's what I was trying to get at. It's just like,
So if you say
if
I want
you're
to
if
delete a channel, then
Mhm.
I can just keep a cache of that was deleted. And if you try and transmit to it again, I'm going to throw it.
Right. Like you're telling yourself to remove the outbound channel, and you're also telling yourself to punch it out, right?
It always gets punched out when you go crush.
Mhm. So it's in the system layer, the system code.
Yeah.
Right. So you might have some userland code that's like asking to talk to a channel that the system is punched out.
Yeah, this is or deleted. Like it's deleted a
Mhm.
channel and then the user code deleted it too, or wanted to talk to it again, and it should have been thrown. It should have thrown, but it.
I think that actually the nicest thing to do there is to like this happens in real life too, right? Like if somebody changes their phone number, like I can try and phone that phone number. The person on the other end is going to pick up and say like, no, wrong number. Like, that's a bad example. Like
Oh
the
no, I
polite
think
thing to
probably
do
what
for
you
the
more
user.
mean is mail when you send it,
Yeah,
and then like 2 months later you get it back saying wrong address.
right. Exactly. The polite thing to do is for the parent layer that's in charge of the state of those things to be like, no, like you can't talk to something that
Oh
like
right, but
isn't there
I
anymore.
can actually do it late, right? Like I can just because you sent something doesn't mean I owe you a response immediately. I'm like, I'll get back to you. And then
Mhm.
when it comes time to process all the transmissions, I'll just send you back a message that says failed or rejected because you're an idiot. And then next time the block process runs, it's gonna need to run another block to receive that message, right?
Mhm. No, I mean the other thing you could do that would always prevent this is to like push the loop back all the way up to the pool.
I don't know why I hate that so much.
Right. Like,
Um,
okay, so it struck me when I was writing that there's two different loopbacks, right? There's the loopback where I expect to be able to talk to myself synchronously. Um, and then there's the asynchronous loopback. Like there's some types of actions that like, they belong in the next frame. You say this
oh
in
yeah,
a
yeah.
in
So
a
so so maybe I can skip ahead here. There's an action I want to supply that's called block break,
right.
where when you call that, block ends. Next
Oh, cool.
block. And so the design that I've got at the moment allows you to stop processing at any point,
Mhm.
and you can carry on. And the only sort of rule I've added is that from one block to the next, like something on the network channel has to have changed. Either like I think it's entirely valid to call it a block, even if all you did was add more pool more interblocks. Even if you didn't process anything, if you all agreed that this is a block, then yeah, that's a block because it contains valid information, but you should get on to processing that.
Right. I guess it doesn't actually even solve the problem because you don't know whether the command to address the deleted socket is after the block break. Like even if you
I think
tried
it
to
doesn't
move that
matter
action to
because for the way I had loopback going is that it's always asynchronous.
a,
It
oh,
you
okay.
you don't know if like you call it the same way you call a foreign chain. It's just that the rule that I'd implemented is that I will always exhaust loopback before calling block end.
Mhm.
But now that now that I talk to you about it, there is no reason for that rule. That's an old rule, And so you can freeze loopback. If you call block break and there's still a bunch of actions pending on loopback, I think it's entirely valid to just go halt, and that's now part of your receive set that you'll need to process later.
I'm pretty sure I would want to punch the programmer that used that mechanic, but
why?
That's like a continue statement. It's just like, no, just end the loop. Like, I get it. You're worried about resources and time and whatever, but like, it's just a break in. It's just a break in control flow, right?
I think block break's a valid thing to use sometimes.
Yeah. I mean, hey, you can't, like, don't get me wrong. There's still go-to statements in JavaScript. You could still use them.
I know, just because you can, though.
But actually, I mean, that's a good point. I think if block break is designed right, like, I mean, yes, you're technically asking for user space to care about,
it's
like system level thing. But like, if it's designed right, it should have minimal disruption on the process.
Yeah, I think so, and I think it can be. And it's just simply, if the mechanics of channels right now, because they have an ID, which is independent of whether they're resolved or invalid or what, and they have a linear counter that counts every action right from since their first action they ever sent, it sort of doesn't matter. You can halt at any point with any number of pending actions, and it's completely fine.
Yeah, I diverted us again here.
I mean, look, man, this whole I think diversions are good because
I know
that's how we get ahead. The block breaking use case that I specifically had in mind was if you were doing some heavy processing and you knew that the chain time limit was coming up soon, or you simply wanted to be receptive to other control flow. So it's sort of like calling yield on a thread, and I forget which language. I think that's Java or something that I'm recalling there. But another system I'd like to add later is the ability to do yield within this system, which I think is to allow you to resolve a promise multiple times. So you can get back to someone and say that it's not just a promise, it's a yield, it's a generator promise, and then you can send back resolves to that action arbitrarily many times, provided there's some sort of internal numbering system that gives you sequence on those things as well.
But you're talking about like coroutines, like shared concurrency.
Yeah, something like that.
Yeah.
But I guess that's a good segue into the ORM model, because upon thinking about it a lot more, remember how I've been talking about using the command line as a way to, because of the way covenants are defined, if I say that your actions need to provide a schema for what their parameters are, that means that I can then auto-generate a command line tool or a GUI tool that knows what JSON needs to be inserted where. There's really no difference to that and wrapping the object with some functions that I auto-generated from the schema that I knew that the foreign reducer needed. And so I can just call those functions. I can allow an ORM style interface where you get back an object that represents this foreign chain. It has functions on it that are asynchronous functions that are auto-generated based on the foreign covenant. We could also do what Prisma did and generate it ahead of time so that the types come through as well, so that you get all that typed information on them too. And then when you call them, they simply take the arguments you supplied and after verifying them, convert them into an action, send them to the other chain, and then await the response. And then you've got an ORM interface that's just objects.
Yeah. You might want to look at like more generic RPC schemes, because it kind of sounds like it's there too, right? Like what you're talking about to me reads like it's like thinking in the same space as gRPC or GraphQL too, right? Like you define the types of objects that are going to be moving across the wire, and then you kind of build a bit of a header, like explaining what are the functions that you expect to exist on the other side. And like definitely with actual RPC, that's like an action system underneath. So like the way gRPC works is it turns it into actual like action objects and then sends those across the wire and invokes the function on the other side.
Yep. That's what this is. I mean, that's what the entire system is, basically.
GraphQL, I didn't realize actually until I started playing with it a lot that it is an RPC scheme too. Like
you can do
mutations
are based.
Yeah, mutations are basically functions that you're declaring right on the type interface. And like you're saying somebody exists on the other side to fulfill this, right? Like
so I mean you could write a GraphQL translator so that you could operate on these chains using GraphQL and no API, no server in between. It's just direct chains.
Yeah. I think that's a killer like idea, right?
That's probably better. That's better than giving it like MongoDB style queries where you like search by blah 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 and it searches through all the child chains. It's maybe better to just skip ahead to a GraphQL. That's a better query language.
It is. I mean, honestly, you know what? Like, it took me 1 month to wrap my head around it, and like ever since now, if I try to write REST, I'm like, I just want to find someone and kill them. Like,
yeah, right. That's kind of how. Yeah, it's partly why I need to get this thing working because I'm not sure I can do traditional systems anymore.
Right. Yeah. So you could, in fact, like. I like the idea of using the minimum kind of like in-band like language set that you need to declare this is how the actions work and this is what to expect on their parameters. I believe you could probably make that spit out a valid GraphQL schema and like a valid set of GraphQL resolvers that you could just plug right into Apollo. So you could literally like you could instrument this, like say basically spit out the GraphQL version.
What do I need Apollo for?
Well, I mean, you just want, if you're thinking about pluggability into current frameworks, right? Like,
so like instead of saying, okay, you have to rewrite your front end to have this ORM included in it, we'd be saying if you've already used Apollo, you can just do this straight. Okay, so we could then provide an adapter in the browser that would act as the endpoint for the Apollo in the browser. And so Apollo would think it's talking to a server, but really it's talking to a blockchain instance in the frame. And that would do all your apps just ported instantly.
Literally. Like you could actually make a mode on the browser instance of IPFS saying like, just start synchronizing these objects with the rest of the IPFS network. Like you could start the database in the browser and have it magically like percolate out to a million other nodes from there once you've decided this is the actual run I want to keep.
Yeah. Yeah, okay. Well, I'll see if there's a nice spot to insert the GraphQL thing. At the moment, inserting the ORM thing seems trivial because it's just sort of what I was heading towards anyway, but just much nicer. Like it's more, it sort of like folds it in on itself, so it gets it back to, I don't know why it's so natural to talk at something rather than imagine you're in something and talk out. It's just easier to imagine you're not part of the system that you're affecting, which is probably why global warming, but still, that's that's sort of how that's where I'm at with that. I think the API from Prisma is just nice and very doable for us in terms of that's how you use this system.
Right. So you give it a header file basically, and then it turns into a living little like robot that does your bidding.
Yeah,
right?
Pretty much, yeah.
Yeah, I really like that way of. Yeah, I mean, the only nicer DX that I could think of on top of that is like when I poke the robot, it gives me a JSON object, and I use literal like JavaScript mutations. So I don't know if you remember the what's that state library? Immer, yeah, the Immer style, where like you pass it a function.
That's so nice. Yeah. Because I was imagining I'd give you an object, and I'm like, how do I handle updates? Well, I could just update it for you, and then magically this thing's changing under your nose, or you could subscribe and I'll give you a new object. But you're right, man. Like Immer style, where you're like, here's this object, and when you make a change, it's like if you just write it in an Immer function, like produce, and then when you go produce, or it's same with like immutable JS, how you do with mutations, and you then supply a function, and it gives you this object that you just mutate directly, and then at the end it commits it.
Yeah, you don't even need to return it, right? Like you're not even you immediately forget about the function semantics, and you just start mutating stuff, and then it just like keeps track of all the calls on the proxy, and then turns those into actions.
Yeah, or because it's just state mutation, it'll end up with one diff at the end that it would just push out to the remote chain and say, I want these changes, please.
Right. And like that's actually pretty easy to plug straight into like a GraphQL adapter.
Right.
Because then you're just like
That's a beautiful way to do changes. It's like here's an object representing the state of the foreign chain. Change it any way you like, and then when your function ends, I will then apply them to the remote location for you.
Right. And it's all type safe.
Yeah, can be. And there's no like it like yeah, no, that's cool. That's cool. Well, I'm glad we have deviations because yeah. So the ORM stuff, or that crush, uncrush, get diff, there's nothing really you can see there that needs improving much more.
Well, so again, like the only thing I can think of is like crush. I think it's probably already covered by the like layered structure in the communication layer, and like the way that the rejoins work. But like crush, like how do I tell crush what it's deleting? Is that something that we're only letting the system do?
You mean when you're deleting a channel, or when you're deleting a key?
When it's punching anything out, right?
Everything that becomes a CID is considered punched out, and it's now over to the caching mechanism to decide how much to keep around or how much to just persist and transmit.
I guess what I'm actually asking is like, does anybody do that in userland?
I have steered away from that topic because I think there's a problem with your design if you have a state so big that you're trying to process in a chain that needs that.
Right.
Just based on the sketches that I'm doing with the apps. But that's not to say that it isn't a useful thing. It's just that I can't seem to think about it right now, and I don't imagine it's terribly different to how it would work for the system anyway. It's just when it comes time to block, I check that your CIDs match the data. I make sure I can fulfill it. If it all works, then I just treat it as part of the chain, I think.
Right.
I think that's. I can't imagine it's more complicated than that. That's sort of why I sort of not dealt with it now, because I'm like, I don't need it, and I think it's simple.
Right.
I don't need it
Yeah,
yet,
I
I
mean,
should say.
there's nothing I can really like think of on this schema that like doesn't make sense to me.
Okay, so here's the
Um,
tricky bit of that schema then. The
yeah.
tricky bit is I tried to design it so that it now mirrors the state machine that's going to execute it.
Mhm.
And that starts to feel over-constrained.
Mm.
Maybe that says that I've designed the structure wrong, but it is my goal, based on your suggestion, that
Mhm.
the state machine that processes the blocks should look an exact mirror of the block structure itself, right?
Yeah, I mean, basically, like
Because
just in
block is the context of the state machine that processes the block.
mhm. What I think is just like um, if you're really going to break the block apart into like multiple pieces that fulfill different semantic roles,
Yeah,
then you have a responsibility to make sure that the machines like correlate to those pieces and to those roles.
yeah,
So like this is more about how the state chart is composed of like sub-state charts,
yeah,
right?
and that's what I tried to. Um, the block is composed of sub blocks that
Right.
represent the sub charts.
Right. And the machine is composed of sub-machines, right?
Yeah, which map in my head so far. I haven't actually written that machine, but map in my head directly to the block's structure.
Yep.
And
Yep.
when you go to do a different thing in a different state machine, you are now in a different area of the block.
Mhm. And likely what you'll see is that results in a lot more um, back and forth communication than you used to have.
What do you mean back and forth?
Like if you had before a state machine that like dealt with regions in the state in a cross-cutting way, um, like you can basically like address this piece and then address that piece and then address that piece in the code inside the
Yeah,
state machine.
yeah,
Whereas if you cut that into three separate state machines, those have to become actions that are traveling between those state
yeah.
machines
Or
now,
well,
right?
transitions where you
Right.
move to that other state. Yeah. So okay, well, I'll keep persisting with it then. It was just feeling like maybe this is the wrong path, but after talking to you now, I'll keep going with it, because you're right. It says that probably the problem is somewhere else other than that goal.
Right. What I'm trying to get at is like before, if you had a leaky abstraction, you couldn't tell. Now, if you have a leaky abstraction, it will literally like the logs will grow super fast in a state machine, right?
That's a great point. That's a great point. It says that either my state machine design is wrong or my block design is wrong if they don't match.
Right. Like at the end of the day, what you're really trying to do is you're trying to like um, you're trying to give an audit trail to everything that's happening inside this process, basically, right?
Um, more than that, more than that. I'm trying to make the block be that audit process where a block simply represents a stopping of that process at any allowed point.
Right.
And so that the consumers of this system should be able to look at that state machine of how the block's working and understand how they are to interact with it and why it does certain things, why design decisions were made a certain way. When they go to debug their own code, they should not feel like they just walked into the jungle in our code. They should feel
Right.
like we are basically a laboratory for their code, and they should use us as tools to assess their code deeper rather than fearfully tiptoeing around the edges of the jungle in all sorts of unholy ways.
which is literally what leads to code bloat right now, right?
Yeah, right, exactly. And because I want to, when someone sends me a fault, they're like, I tried to do this in your system. I'm like, send me the IPFS link to the block and
Mhm.
I'll rerun the exact thing that just happened for you and I'll get back to you.
Yeah, it's like forensic computation.
Yeah,
Um, it
yeah,
like I totally feel you. It's like if we haven't made a system where like you could pick up a block that failed partway through
yeah,
and like fix the problem and keep running the block,
yeah,
like if there's any opacity to the system level
yeah,
performance and
that's
behavior,
it.
that
Yeah.
then like we're just in the same situation we started in,
we
right?
just fucking, we just made the same prison all over
Yeah,
again. And we
yeah. So
lost like the greatest tool that I can imagine for debugging, which is I can look at my production code, go back in time, fork it, and keep going. Not like be like, okay, I've pushed a change that added a bunch more logging around the area we're having problems in.
mhm. It makes me see the goal of like hot patching the core a lot more clearly too, right? No,
Yeah.
it actually just makes me even more committed to the idea that like, to be honest, if you feel it's over constrained to write that small of state charts, like I would challenge you that you probably still aren't even writing small enough ones. Like at
That's
the end of the day, the state chart might actually be like literally like one address in this object and the value in it. Like it might need to go that small in order to have this outcome where like I could pick up the log of what's happened so far in the state chart, even if it's like super core system level kernel functions, and like change the version of the kernel that I'm running on it
yes,
partway through and just keep
yes,
going.
yes, because in the schema, I have treated the kernel as just another covenant, which has a chain ID and a pulse ID for what version of code it is. So if you want to patch the kernel and then keep going, same as patching a covenant.
Cool.
Um,
You're going to back out a hypervisor one way or another, is what I'm reading.
you know what? Sorry.
You're going to back out a hypervisor one way or another.
What do you
You,
mean?
I mean, a sufficiently instrumented like core process,
Yeah.
like that's capable of logging like every single like micro change inside of it. Like honestly, tell me like that can't possibly be that hard to turn into literal actions and like run as a chain. If you know that every single like atomic change that's happening to every piece of
Yeah.
the state is tracked in a log, you've written the hypervisor from the outside in.
You're right. Because I can go from deterministic state to deterministic state, it
Mhm.
almost doesn't matter how much happened in between. The fact that it's replayable makes it the hypervisor that can be interacted with like a chain.
I think that's an ideal that'll get there eventually, but I think in the intermediate time, like what you'll end up with is some chunks of what you're doing are
Yeah,
um,
yeah, that's what I'm saying,
not
right?
quite deep enough yet.
It's not quite there, but at least it works, and I can see it evolving into that's what you meant, right? Backing out a
Yeah,
hypervisor incrementally out of this thing. It
right. You're brute forcing the hypervisor is what you're doing.
well, evolving it. It may have been a little much to try and do it first, maybe. um, do you have much more time? Because if you do, I'll need
Yeah,
to just pop and grab a charger.
yeah. I can
And
go for half an hour.
okay, cool. I'll be back in like 1 minute.
Yeah.
Are you there? Shit, am I here? I think I'm here. Hello? Oh, you're back.
I can't hear you.
You can't. What about now?
Yep.
Hey. Okay. Let me just check if the stream picked up again. Oh, yep. Magically, the stream restarted. Okay. Sorry about that. Thank you. My laptop shut down.
It's all good.
So I haven't. Okay, so we've covered everything except Ukraine, I think. And thank you for the, what's the word for it? Reinvigoration of sticking with that, keeping the block structure the same as the state machine structure. I was having doubts, but I can see now that actually that's a sign of another problem. So I'll keep.
Yeah, well, it should actually even allow you to isolate the hot paths a little bit, right? Like there will be one machine that has like 50,000 lines, while another machine has 2, right?
Yeah.
And like that might be just necessary, but like at the same time, it's a it's an easy way to visually see that like this thing is being overloaded.
Yeah. Yeah, you're right. Okay, so you sort of gave me some reassurances around the crush, uncrush, diff thing. Sounds like it's good enough to work. The delays in fetching old state sound like a simple fix is just to, pull first, then block, then transmit at the end.
Mm-hmm.
That seems easy enough to implement, and then I'd feel safe against that. It might not even be a problem, but it's just the fact is that I cannot tolerate the block time being variable in any way. It should be as quickly as possible. Yeah, okay, so Ukraine. I had an idea.
Okay.
So I got, made a bunch of friends over there. There were also all the guys in Kharkiv that we used to work with. They were working on the Dreamcatcher and this blockchain while we were there, and one of the problems that they're having right now is censorship. Also, information transmission while their networks are being interfered with, or they're offline, or they can't get to a particular network. We had, particularly Scott and I had talked a lot about using warfare scenarios as means of generating a good spec for what Interblock had to do, because a lot of the time the features we were striving for didn't really become critical to you until wartime. Like a lot of people don't care that their SaaS accounting system runs in a cloud or can run independent of a provider. It's just not that big a deal of it to them. They're just happy that it doesn't cost that much, and they just want to get back to whatever they were doing other than worrying about their software. So But now that we have a war, some new kinds of problems are occurring. And I understand that it's a complicated subject for everyone. If it makes you uncomfortable, I'd totally be fine if you just called stop at any point.
No, I mean, I want to say, like, global nuclear war was part of the design scenario for TCP/IP. The thing
Yes.
you're talking about is like a very well trod path, right?
It was the reason for the internet was nuclear survivability, but they did not at the time include computational or storage survivability. They only included transmission, and we've come a long way on that, but it's time to move to the next level, which is objects. Objects need to be strongly survivable as well.
Yeah, I agree with that completely.
Yeah. Now, it's rude to turn up to Ukraine with a solution for them. What's not rude is to turn up with a seed and say, look, here's some basic protocol primitives. Here's an ORM to a distributed system. Here's a method for managing fundraising in a trustless way to build things. Why don't we help you build the tools you need where only they can really know what they need, because anything that we think of is, quite frankly, rude. It's a guess. It's like 10,000 Ks away. It's probably wrong. And it might not get even adopted by them. They might not care.
Yeah, I mean, you gotta ask people what they actually need.
So, a friend of mine is Ukrainian and also lives just up the road. So, I was lucky enough to have talked to her for about a couple of hours the other day. And she was telling me about some of the problems they're having with journalism over there, where they can't post the photos of what's happening because the photos are too horrific. Social media platforms won't take them, and so they've ended up forming large Telegram groups where things get posted and shared around, and it's a very manual process. I proposed that perhaps the Ukrainians would benefit from, number one, the Dreamcatcher being used as a means for gathering requirements, coordinating funding, and people to build some tools that they need that operate in an uncensorable way, including, of course, building out the rest of the features of the blockchain. I mean, once I get it working on IPFS, I think it's enough to demonstrate the concept, but it will need a bit of tuning and hardening and all that.
I think there's going to be a hardware layer problem too.
What's that?
Like, I mean, I don't know. Like, it seems like their physical network infrastructure is like really gummed up and like being regularly taken offline. Like, there needs to be some kind of more resilient networking means, like, in order to actually
there's
allow.
Starlink.
Yeah.
And but IPFS in its form today deals with a lot of those problems. Like, it can do auto discovery on a local network. So you can basically connect to a Wi-Fi network and find other peers and then synchronize things that are of importance with them. So that,
I guess you could probably do that on a VPN too, right?
yeah, Yeah,
Okay.
but so I mean, like, the thing I love about IPFS is that you could have a home server, and you could also run like validators on some friend servers, and you could sort of sneakernet data around, and you should be able to sort of keep each other in sync in that way, and hopefully when one of you gets to the internet next, you can upload for everyone else. So solving the hardware problem is not something that I can do anything about,
Okay.
but we can make maximum use of what is there, and I think IPFS does a really good job of that. IPFS is doing it right now. Our layer, this feels closer than it's ever felt before. Once this starts working on top of IPFS, we'll pretty much be in business, because IPFS does all the hard bits. It's just we don't have privacy. That's not really a problem in the war yet. So anyway, very concrete systems that I proposed. Do you know about Hootsuite? Have you seen Hootsuite or used Hootsuite?
Yep.
Yeah. So I was proposing to them a blockchain-based version of Hootsuite. So instead of posting images to Telegram, you post images to our version of Hootsuite. It gives you the uncensorability aspect straight from there, and then you post links into Telegram. And you can also connect up your social media accounts so that as soon as you get to the internet, we will attempt to post these images to your social accounts with arbitrary delays or whatever, plus with like multilingual captions and things like that. So basically, if you can get it into our app, we can give you the uncensorability part, and then we can do best effort to the existing channels that you have. Whether or not they get censored, well, that's sort of not up to us, but at least we've got this repository of information that can't go offline type of thing.
Yeah. Okay. So I want to take one more pass at the, like, I know it's not a problem. We can't solve hardware problems, but
Yeah.
I would want to see a concrete plan for replication out of the state boundary, basically. Like
Sorry?
that's the main thing I'm worried about there, right? Like I'm sure it's actually not a problem, but like, it seems like you haven't actually solved the problem until you can guarantee that some of the replication is happening outside of the Ukraine, like in Europe, in North America, Like,
Right. That seems easy though, because
right. I mean, it's how IPFS works, right?
well, not exactly. IPFS needs to be told to fetch something. So in our case, I'd imagine that a reporter fires up their hoot chain. I would take my hoot chain in Asia Pacific. I would subscribe to that reporter's hoot chain so that I received updates from them anytime
Okay.
something happened. I would then choose to auto pin that so that I always keep a copy, and then I would also broadcast on the unmodified IPFS network. I would also provide all the information for that chain from anyone else. So any other subscribers who were following that hoot chain could fetch from me as well as from them, so that their upload is treasured and precious, intermittent, and not burdened, and I will replicate for them because I believe in what they're doing.
Okay. Yeah.
So I don't even know what I'm saying or asking. I'm just it feels like everyone should do something about what's happening in Ukraine. This is as good as I could come up with. And just so happens that our system has been working off of a warfare model for some time. That's what we've been designing for. Our main team was in Kharkiv. It sort of feels like if we could just find a way to not be rude about it, it seems like a really nice thing to do.
Yeah. So, I mean, I think the main thing to do would be to figure out what's the delta? What does it take to get there? You know, I can put some real hours into it. I mean, fuck, it just seems like I'm going to be working all the time anyway right now. So why not work on something fun?
So I guess.
And then the other thing. The other thing is, like, I think we need to be really conscious of the fact that, like a big part of this is going to be an effort to actually document what all this means and how it works and like how you might want to use it. Like, I feel like the code delta is probably not that much, but the explanation gap is huge.
And it's not even in English.
Right.
So what I was thinking of doing was, I think that my friend can find me some reporters that I can get specs off of. And if I can get them to agree to provide those specs in an open format, such as like have a YouTube streamed interview with me where they explain what are the features of their tool and what are the problems that they're facing, and then I can start to work on a prototype with them. Then if that is useful to at least a handful of reporters, surely it will be useful to others. And then we can tackle how do you get the word out from there. I mean, they're specialists in getting the word out about whatever they choose to get the word out about, right? So that was all I got. I mean, it just seems so pointless in the face of like what's actually happening, but like that's a very real problem for them, getting pictures out and saved in a way that there's no you can't debate that the picture was altered or anything like that. So part of what the system I was proposing would, first of all, it would peg to Bitcoin so that you can be assured that this photo definitely occurred within this 10-minute window, or it was at least generated within this 10-minute window and it hasn't been altered since then. But also a tool to allow identification within the photo of who people are, so mapping like other hoop chains or identity chains, tagging them in the images. But the critical feature that I only sort of understood when talking to what these people are having problems with is a web of trust that says, I know this person knows this other person, and this person took the photo. So as the images get passed on, they get like, when you receive an image, you'd sort of have to say, I looks real to me based on the chain of the provenance of where the image came from. So basically a way to not just provide an image, but also to provide irrefutable provenance of where it came from, who passed it on, how do you know them, the social graph that shows how the image arrived to be seen by you.
Yeah. I mean, like it's a social network is basically what you're describing.
That's exactly what I'm describing, which in the most respectful way possible is kind of what we've wanted all along. Like, I just cannot bear the thought of it being seen like we're celebrating that there's a war in Ukraine.
Yeah.
Making a social network was one of our dreams. I just had never intended it to be in as solemn circumstances as this, but only in this type of scenario is our social network clearly a better design than Facebook.
I mean, like the way to avoid being seen as opportunistic is like making something that's valuable regardless of whether there's a war happening.
I mean, we're not trying to make
And
money off it. We're certainly not going to be trying to put ads in for, the top of like images of war casualties. So,
yeah,
there's that. Um,
the blockchain peg, that'll be expensive, I think, to operate, won't
no,
it?
man, no. Because remember how I was saying that the goal of Interblock is all the world's information as one hash,
Mhm.
and that children, whenever they change, they go up to their parent, which then goes up to its parent. So, really, if you had like a deeply nested structure that had in total a million chains, you'd only ever need to peg the root
Right.
once
So you
every
just,
couple of hours or something.
yeah, you just like once a block, maybe even. I guess that would be expensive.
Be expensive. I'd probably say once a day, but more likely what I'll say is on demand. So that if you something important has happened, you can say I want a peg now, and you can pay for it, or you can sort of share that cost with other people who also want a peg now, because one person in a network pegging is the same cost as pegging everyone, because you just peg the root. So it's kind of just whenever someone says.
Right. And the root chain in this situation is basically like an identity provider.
No, the root chain is just any group of chains,
Oh, I know what it is like in terms of the patterns that we're building, but
right?
for this specific application, like, I mean, maybe tell me I'm naive or like not thinking about this all the way through, but like the main service here is basically like make an identity on the platform and then like you can post things to your identity.
So long as it is added that we don't control that identity,
Right.
yep, then yes, absolutely. Anyone can make an identity so long as you can afford the chain fees.
Mhm.
Um, you can make an identity and you can post anything you like against it, and it's up to those identities to form rings of trust where they
Yeah. So
decide
there's
who's in and out.
there's one feature. Yeah, there's one feature on the identity chain, which is basically the like the lines in the social graph. Like there's an arbitrary data blob that you can post, like a wall almost, right? It doesn't even need to be that structured if all they want to do is put pictures up, right?
Yeah, man,
But
that's all
there's
they
two
want to
functions.
do. That's literally
Right.
all they want to do right now.
There's two functions. One is like post data to the stream, the data stream,
Mm-hmm.
and the other is like claim knowledge of this person, like
Verify.
which is yeah.
Yep. Those are simple features, man. Those are real simple features.
Mhm.
I just feel quite empty about the whole thing, and I'm not sure why. Like, it just feels like building this blockchain has been a lot of fun, even though it's been incredibly testing. Applying it
Yeah,
to something like this doesn't feel like fun anymore.
it's not going to like. I mean, if you want my honest opinion, um, like civilization is collapsing. Um, and like the way to stop it happening is to like let people speak truth to power.
Yeah, that's a good. That's a good
Um,
line. That's a good line.
I like. I have trouble. Like, I'm feeling depressed. Like, without thinking about blockchains, is what I'm trying to get at. Like, climate change is a solvable problem, right?
Totally.
Like, there's basically 50 or 100 oil companies that are causing it. By the way, I have to call out. Um, like, I have to take off here pretty quick.
Okay, sweet.
But like, something you said in a previous call really like stuck with me, which is like climate change is an accounting problem. Like it's literally like somebody says the air is too much commons for us to ever care about our impact on it.
Yeah.
And like, no, I mean it's not.
No.
Like it means that everybody needs to care about it.
To draw on the entropy parallel, the way that we're all acting, there's no higher level error correcting code that looks at all of our behaviors in sum and applies an error correcting code there. There's too much individual drift without a cohesive error correction as a whole, and that's a system that we can build.
And not just can, but like increasingly feels like nothing else actually matters.
Yeah, that's the thing. That's sort of making me uncomfortable, but yeah. Okay, I should let you go.
Okay.
Can you this Ukraine thing? Like, I want to do it, but I'm like, it just doesn't. I don't think I can do it by myself, and I just don't really know how to go any faster than to just keep doing the blockchain and then get the Dreamcatcher and then this thing, but it needs to go faster than that, so I'm just not sure what to do there. It's definitely a use case. We've definitely got journalists in the Ukraine that will help us with specs and also spreading the word and using it. So that's quite a way ahead. Anyway, please give me your thoughts on it.
Yeah, I mean, like, I'm actually pretty excited talking through the implementation stuff that you've got to, and like it's kind of time for me to just wake up and like get working on stuff. I'm letting other things interfere with me too much.
Like I said, man, if money's a thing, we can sort that out too. Let me know. But these are things that have to be done, and I don't really know how to do them by myself, and yeah.
Let me have a think. Let's talk again soon, okay?
Yeah, that sounds good, man. Thank you very much for taking the time today. I know it was a bit of a rough day for you.
I still got more to do.
Yeah.
But it's all good. Have a good night.
Okay, man. You too. Enjoy your sushi.
Yeah. Bye.
See ya.